Hello and good morning. Let's take a look at this EOC Day 3 work. Make sure you're keeping all your work in order so you have it to study for at the end. Anyway, we're looking for rotational symmetry. Rotational symmetry is if you can turn the object less than 360 degrees and you end up with the same object. So if you look at the square, you can turn the square 90 degrees, and if you turn it 90 degrees, it's going to look the same. So we're going to go with that one. This one, if you turn it 180 degrees, if you turn it 90, it would be like that. But if you turn it one more click, 180, it would be rotational symmetry. The triangle, if you turn it the first time, it would look like this. That'd be one click. If you turn it the second time, it would be something like that. The third time, it would be something like this. And then the fourth time. But you can't turn it 4 times because that would be 360. And everything would have rotational symmetry. So this one is a no. This one, if you turn it 180, it should work. So this is a yes. And this one right here, it looks like you could just turn it maybe 90 degrees and have the same thing. So I'm going to go yes on that. All right, now let's take a look here. We're looking for the answers to these questions here. So it says reflectional symmetry on line H. So here's line H. So the question is, can you flip this over and will it land on itself? And the answer is yes. So that one does have reflectional symmetry. Okay? The next one says reflectional symmetry over line G. Here's line G. Can you flip this over? And the answer is yes. Line M is right here. Can you flip it over? Yes. We're going to go with that. Reflectional over line N. Here's line N. And if you flip this over, then these are going to be pointing over here somewhere. And that would be a no. So we're going to say no on that. Rotational symmetry, 90 degrees. If you turn this one click, 90 degrees, it's not going to be enough. Okay? It will eventually have rotational symmetry, but not 90 degrees. 120 degrees, yes. And you might say, well, how do you know that? Well, if you look here, from here to here is one turn, so to speak, and there to there, and there to there. So a whole circle is 360 divided by 3, which gives you 120 degrees rotational symmetry. So that's a yes. 180 degrees would be this one going around, and it would be pointing over here. So that would be a no. And that's how you answer these questions. Let's go to the next page. Work the next page. Page 2. Okay, so let's see what we have here. Which transformation will carry the rectangle below onto itself? It says reflection over line M. Here's line M right here. And if you reflect it, this point is going to go over here, and that is a no. Reflection over the line y equals 1. Y equals 1 is right here. And actually, let me think about that. Y equals 1, this is your y-axis, so it would actually be right here. Okay, so that is y equals 1. So if you flip this point over that line, it would land right there. So that would be a yes. Rotational, 90 degrees counterclockwise. If you go 90 degrees, it's going to be facing up, like that. And so that's a no. And then 270 degrees about the origin. Well, you see, it's not in center with the origin. In other words, the distance from here to here is not the same as the distance from there to there. So you can't turn it and make it go onto itself. So that would be a no, since it's off center. All right, the next one. Which transformation maps it over? Well, this is a flip. If you draw a line right here and you flip this thing over, that would be a reflection. Okay? All right, and down here, select all the rigid motions that describe the pre-image and the image. So the pre-image is the one you start with. So that would be like A, and this would be A prime. Okay? Remember, the prime is the new one called the image. So the question is, what would you do? If you rotate the pre-image 180 degrees, it would be facing down. So that one doesn't work. A glide reflection is a slide. You can slide it over, and you can slide it up and down, but that's not going to work. A rotational 90 degrees and then a reflection over the vertical line. Well, if you rotate it 90 degrees, like that, and then you reflect it over a vertical line. A vertical line. So let me think about this. If you turn this 90 degrees, the question is, how would it look? I think it would look something like this. That's going to be laying flat, and then this is going to shoot up over. I think it's something like that if you turn it 90 degrees. And then if you reflect it over a vertical line, this part, the boot, would be facing over here somewhere. Something like this. Okay, so I don't think that's going to work. Reflection across a horizontal line and then a rotation of 90. Well, let's think about that one. Reflection across a horizontal line. So a horizontal line would be flat like that. And then if you reflect it, it's going to be pointing down. So it's going to look something like, it's kind of hard for me to imagine it, but it's going to look something like this, I think. And then this is going to go like that, like that, like that. Okay? And then if you turn it 90 degrees, the question is it going to be the same? And, right, if you rotate it 90 degrees, now if you go 90 degrees, that's going to be a hard fetch for me. They do have this one marked down. We're going to put it, and I'm not actually seeing it, but I'm going to put it, and reflection across a vertical line and then reflection against a horizontal line. So a vertical line would look like this, and then you flip it over, and then you flip it over a horizontal line, and they're saying that one does work as well. So those are kind of tricky. You're going to have to draw them out and actually try to figure them out. All right, let's go on. Work page 3. All right, which triangle is congruent to triangle PQR? PQR. So PQR is this one. So you want to find out which triangle is congruent. Okay? Congruent means equal. And if you look, this side right here, the distance from here to here, you can take a piece of paper if you want to. You can actually measure like this. So the distance from there to there is here. And if you look, this one looks like the answer. Congruent means equal. So we're going to say this one right here. All right? And number 4, the vertices of the triangle are right here. Under which transformation is the image, the primes, not congruent to that? When are they not congruent? A dilation makes it bigger or smaller. So that one right there would not make it congruent. And if it was a scale factor of 2, you would have to multiply each one of these by 2, and of course that would double the size of the image from the pre-image. All right, number 5, which transformation will always produce a congruent one? Well, if you look here, this one right here is adding 4 or sliding it to the right 4 and then down 3. Okay, so to the right and then down. So you're just sliding it. This one you're multiplying by 2, so you're making the x's bigger. So that's not a choice. This one you're multiplying, it's a dilation. This is definitely a dilation. The only one that would be that would be that one. That's a translation because you're just sliding it. You're not changing it. You're not dilating it. You're not making it bigger. All right, number 6. A figure undergoes a translation, so a slide, and then a reflection, a flip, and then a dilation, so it gets bigger or smaller. Will the image be similar to the original? Why or why not? Okay, the answer is yes, it will be similar. It's not going to be congruent. In other words, the sides are going to be proportional. Okay, and if you read this, it says yes, any number of rigid motions in a dilation will always produce a similar image. So the sides would be proportional, like mama duck and baby duck. All right, the last page for today, try this one. Okay, so you have triangle congruent to that triangle. Remember now, you match the sides up. So let's just do that. So put sides and angles. Okay, so we're going to put the first two, TR, is going to be congruent to the first two, AN. Remember the key I tried to teach you a long time ago? The second two, RI, is going to be congruent to the second two and G. And then finally the first and last, the loop, TI, is going to be congruent to AG. Okay, and the angles are going to be angle T is congruent to angle A. And R will be congruent to N, the middle one. And then the last one, I, would be congruent to G. So we already know that it's got to be those. So let's take a look. TR and AN. So here's TR and AN, check. TI and AG. TI and AG is here, check. RI and NG is here, check. TI and NA. TI and NA would be a no. Okay, so we're going to skip that one. Angle T and angle A, yes. Angle R and angle N, yes. Angle I and angle G, yes. A and N, no. That would be a no, and there we go. Okay, the last one for today is right here. The image of ABC after a rotation of 90 degrees clockwise. Remember, if you go 90 degrees clockwise this way, 90 degrees, you're going to change the X and switch. That's the rule. Okay? About the origin, there's the origin. Okay? So 90 degrees, you would draw a line through there, you would make an X 90 degrees, and so that would put the point somewhere over here. That's where that point should go. Okay, so it says about the origin as shown. What statement is true? Okay, well, apparently this one is, we're going to accept it as 90 degrees on that. Okay, so angle A and angle D is the answer there. Here's angle A, and angle A would be congruent to angle D, and that's the one we're going to go with. Let's see what else they had. BC and DE, so BC and DE. Well, BC is longer and DE is shorter, so you don't want to go with that. You got to go through each one. AB and DF. So AB is this one and DF is the longer one. That's not it. Angle C and angle E. C is this one, and you got to match it up. It looks like it matches up with that one, so we're going to say no on that. And there it is, and there's your review for day 3. Have a good morning. Okay, I tell you what, before we go, I want you to write the rules of rotation. Okay, so I want 90 degrees clockwise, 90 degrees counterclockwise, and then I want 180 degrees either way. So do that right now, and then I want you to exchange ideas for 2 minutes with your neighbor. So this one, you change the X, and switch. This one you change the y and switch. This one you change both and you don't switch. There it is. Those are the rules. Make sure you memorize those. Also, reflection rules. If you reflect over the x-axis, what do? If you reflect over the y-axis, what do? Well, if you're reflecting it over the x-axis, like that, you would change the y because you always change the other one, plus it's going up and down. If you're going over the y-axis, which is this one right here, then you want to go sideways and you change the x. Make sure you know those rules. Have a good morning. All right, let's turn our attention now to MCR. Okay, so MCR, let's see, get your papers and start on this sheet here. Okay, so there are some formulas for surface area, and I'm going to give you those formulas in just a minute. Have a good morning.